All right, welcome to The Explainer. Today, we're going to talk about solar power. And look, it's brilliant, it's powerful, but it's also way more complicated than you might think. We're going to break down its huge potential, the very real problems holding it back, and what the future really looks like for turning sunbeams into the electricity that runs, well, everything.
Okay, so to get started, let's just try to wrap our heads around the sheer scale we're dealing with here. Every single second, our planet is getting hit with an insane amount of solar power. We're talking 173,000 terawatts. I know, that number is so big, it's almost impossible to picture, right? It's basically meaningless without some context.
So here's the context you need. The sun beams down more energy onto the Earth in just 1 hour than all of humanity uses in a whole year. Let that sink in for a second. And that right there is the big question for today, isn't it? If we're swimming in this endless, totally free energy, why in the world are we still dealing with power shortages and burning fossil fuels?
So to figure out what those challenges are, we've got to start with the science. And honestly, the way solar panels actually work, it's kind of like magic. It's this brilliant real process that takes a tiny particle of light and turns it straight into electricity. Okay, so at the heart of all this is something called the photovoltaic effect. That's the science magic I was talking about. It all goes down inside these things called solar cells. And these cells, they're usually made of silicon, which is pretty amazing when you think about it. It's the second most common element on the entire planet. And yeah, it's the exact same stuff inside our computer chips. So how does it actually work? Well, you can think of it like a four-step dance. Step 1, a photon. That's just a tiny particle of sunlight slams into the silicon cell. Step 2, the energy from that photon is just perfect to knock an electron loose from its atom. Step 3, the solar cell has this really clever built-in electric field. It's like a water slide basically, and it pushes all those free-floating electrons in one direction. And step 4, that constant flow of electrons, well, that's it. That is electricity. Specifically, it's what we call direct current, or DC. But hang on, there's a little catch here. It's a small detail, but it's super important. The power coming out of a solar panel is DC, like from a battery. The thing is, our homes, our TVs, our refrigerators, they all run on something different called alternating current, or AC. So that DC power has to go into a little box called an inverter. Its only job is to flip that DC into the AC power that we can actually plug our stuff into.
Okay, so the science is solid, right? It's elegant, it works. But going from a single panel on a roof to powering the entire world with solar, yeah, that's where things get complicated. We start running into some very, very real challenges.
Which brings us right back to that big question from the beginning. Look, the problem has never been the amount of sunshine. The sun gives us more than enough. The real problem is our ability to capture it efficiently, to store it for when it's dark, and to move that power to where people actually need it.
So these hurdles, they kind of fall into a few big buckets, and they all play a role. You've got the limits of the tech itself and, nature. Then there's the huge challenge of storage and just our existing power grid. Of course, you can't forget about money and politics, and then there's us, the human factor.
So let's start with the first barrier, technology and nature. For all the amazing science, most of the panels you can buy today are only about 15 to 20% efficient. That means they're only converting a fraction of the sunlight hitting them. And then you have the big, obvious problem. The sun goes down every night. And a really cloudy day, yeah, that can slash your power output. This on-again, off-again nature, what we call intermittency, is solar's biggest Achilles heel.
All right, barrier number 2, money and politics. And this one's a big one. The upfront cost to put solar panels on your roof can be really high for a family or a small business. And remember that whole sun goes down at night problem? The solution is batteries, but man, they are still super expensive. And then you get into the bigger picture. You have these incredibly powerful fossil fuel industries with a ton of political sway. And in a lot of places, the government incentives you'd need just aren't there, or they come and go.
And the third barrier, well, it's us. It's people and our habits. A lot of folks just don't really get how solar works. And there's this fear about maintenance and how complicated it all is, even though modern systems are pretty much set it and forget it. And then there's just, inertia. We're used to the way things are. It's just easier to stick with the power company we've always known than to make a big change.
So you have this beautiful dream, right? Just cover all the deserts and panels, put them on every roof, and bam, clean energy for everyone. But that dream crashes right into a really complex reality. We actually need that land for things like farming and, nature. We absolutely have to have a backup plan for when it's dark or cloudy for days on end. And yeah, the sunshine is free, but the gear to catch it and get it to your house, we're talking trillions of dollars in infrastructure costs.
But look, even with all of those challenges, this story is far from over. Actually, the momentum building behind solar right now is absolutely undeniable. The path forward isn't simple, not at all, but it is getting clearer every single day.
So, what's the biggest reason for this shift? One word: cost. The price of solar panels has absolutely plummeted. We're talking a drop of more than 80% in just the last 10 years. That is a total game changer. It means that in a lot of places around the world, it is now cheaper to build a brand new solar farm than it is to build a new coal or gas plant. That completely flips the economic script.
And that brings us to what the future really looks like. The goal isn't really a world that's 100% solar. That's probably not realistic. The real goal is to build a smarter, tougher, cleaner energy system where solar is a main ingredient, working hand in hand with a whole mix of other clean sources. So what's in that mix? Well, you've got solar, of course, on rooftops and giant fields, even floating on water. You mix that with wind power and hydropower. But honestly, the two things that make this whole puzzle work, the absolute keys, are number one, getting massive, affordable batteries to store all that power, and number two, building smart grids that can juggle supply and demand second by second.
So here's the bottom line. The sun gives us more than enough juice. The tech to catch it is already here, and it's getting better and cheaper literally every day. So the final question really isn't can we do this anymore? The question is, how fast can we do it? It's a question of speed and a question of will. How quickly can we build the batteries, the grids, and the systems needed to make this clean energy future a reality?